Hi guys, let's today understand what is stability and instability in the atmosphere. First, let's talk about what is stability. Suppose I have a ball over here and I put some force and make this ball rise up. When I remove the force, the ball will come back to its original position, which means that it is stable. Similarly, if I keep the ball here and I apply force on either side, the ball will keep on moving down and it will never come back to its original position, which means it is unstable. And in the third case, if I put some force on the ball will travel some distance and it will neither come back to its original position nor it will move forward, then it is termed as indifferent. Okay guys, so first let's understand what is DALR, what is SALR and what is ELR. DALR stands for dry adiabatic lapse rate, which is for dry air. By the word adiabatic, it means when there is no exchange of heat with the outside world and whatever temperature changes are occurring, they are either due to compression or expansion of the air. So DALR stands for dry adiabatic lapse rate, which is basically the rate at which the dry air will either be cooling while moving up or heating while moving down, which is 10 degrees Celsius per kilometer. Then I have the SALR, saturated adiabatic lapse rate, which is 5 degrees Celsius per kilometer. This is for the saturated air. And then we have the environmental lapse rate. That is basically how my environmental temperature changes with changes in height, and it is variable with time. So guys, let's first understand the stability concept through an example. Here I have a parcel of dry air at the surface level. I know as per ISA the temperature at the surface is 15 degrees Celsius. So this parcel also has the same temperature. I know that my environmental lapse rate or the lapse rate as per ISA conditions is 6.5 degrees Celsius per kilometer. So at a height of 1 kilometer, my environmental temperature will reduce to 8.5 degrees Celsius. Similarly, my dry air has a lapse rate of 10 degrees Celsius per kilometer. So when this parcel of air is forced to rise up, the parcel will expand due to reduction in atmospheric pressure, due to which it will cool down. The rate at which the dry air parcel will cool down would be the DALR, that is 10 degrees Celsius per kilometer. So at a height of 1 kilometer, my parcel cools down by 10 degrees and my environmental cools down by 6.5 degrees. So my parcel has a temperature of 5 degrees and the environmental temperature is 8.5, which means my parcel is cold and denser. So it will sink back to its original position, and I would say that the air is stable. So as we saw in the example, if my DALR is greater than my ELR, my atmosphere is said to be stable for the dry air. But if my SALR is also greater than my ELR, then the atmosphere is said to be absolutely stable. So let's consider another example. This time our environmental lapse rate is 15 degrees Celsius per kilometer. So at a height of 1 kilometer, my temperature will reduce from 15 degrees to 0 degrees. But my DALR is still the same, 10 degrees Celsius per kilometer. When my air rises up to a level of 1 kilometer, the temperature will reduce and become 5 degrees. Now I can see that my environment is colder than my dry air. My dry air has a temperature of 5 degrees, but my environment has a temperature of 0 degrees. So my air being lighter will keep on rising up, and this will be termed as unstable. So if my DALR is less than my ELR, then the environment is said to be absolutely unstable, because I know that if 10 degrees Celsius per kilometer is smaller than 15, then the 5 degrees Celsius, which is the SLR, is automatically smaller than 15. So the last thing that is left is conditional instability. In some cases, my DALR will be greater than my ELR, which will be greater than my SLR. So in this case, my environmental will be stable for the dry air and it will be unstable for the saturated air. That is all for now. Thank you so much. See you in the next one.